Hi guys, this is the 3.3 notes on polynomial identities. So what we're going to start off with is some certain identities that we can use, and these kind of help you skip over some things when factoring and uh, going the opposite way as well. Okay, so the first one is called sum and difference. This is where we have two binomials being multiplied by each other, but one has a plus b and one has a minus b. So the only difference is the operation inside. One is addition, one is subtraction. The answer will always come out as a squared minus b squared. The reason is because the terms inside um, are going to cancel out. Right, this always works. Right here we can label our a as our x term right here. B is 7. So if we say a squared minus b squared, right, then it's x squared minus 7 squared, or x squared minus 49. And that's our answer. Okay, so that's called the sum and difference, right? If you have the same binomial except the operation's just opposite, then your answer is going to be a squared minus b squared. The next one is difference of squares. Right? So if we have a squared minus b squared, right, or a minus b squared, right, it comes out to a squared minus 2ab plus b squared, right? So most of the time you're going to be given in this form right here, a minus b, and that binomial squared is always going to come out as a minus 2ab plus b squared. So again, in the example, we'll label our a and b. Our a is 5x, and our b is 6y. Right, we know our answer is going to come out as a squared minus 2ab plus b squared. So let's substitute them in. Right, a squared, so 5x squared minus 2 times 5x, and then b is 6y, and then plus b squared, right, which is 6y squared. Okay, then we just clean it up. You got to square the 5 and the x. So 5 squared is 25. X squared is x squared minus, let's see, 2 times 5 times 6. So 2 times 5 is 10, times 6 is 60. And then x times y, so 60xy. And then the next one, square the 6, so plus 36y squared. Okay, so you could just expand these and multiply them out using FOIL method, but these polynomial identities help you skip some steps as well as work backwards. Say we're given a big quadratic, we can factor backwards. Next is the sum of squares, so almost the same exact thing, except we have an addition sign instead of subtraction in front of the 2ab. Right, so our a is 3x, b is 4y, so a squared, so 3x squared, right? I'm just rewriting it in here and substituting in. Plus 2 times a, 3x, times b, 4y, plus b squared, 4y squared. So we get 9x squared. 2 times 3 is 6, times 4 is 24, xy, plus 16y squared. All right, it's much faster than doing the, if you can remember the formula or see that formula out, it's much faster than foiling out. We also have cubes. So this is when we have two numbers cubed, right? So you'll see like a minus b cubed, and then sum of cubed would be a plus b cubed. Okay, so this is our formula: a minus b times a squared plus ab plus b squared. Okay, so a is 2x, b is 3. So we get 2x minus 3 times 2x squared plus 2x times 3 plus 3 squared. Then we can clean it up. 2x minus 3 times 4x squared plus 6x plus 9. And there's our solution. And then last one, same thing, except you'll see it's a plus b in the front, and then a squared minus ab. Right, so just remember when you're substituting in. So a is our x, b is 4y. So a plus b, so x plus 4y, times a squared, x squared, minus a times b, x times 4y, plus b squared, 4y squared. So our final answer is x plus 4y times x squared minus 4xy plus 16y squared. And again, the cubes definitely save you a bunch of time if you're given a nice sum of cubes or difference of cubes. Now, in the first example, what we're going to do is we're going to use those certain tricks that we kind of went over, those identities. They're called identities, but they're mostly tricks, right? And so in A and B, we're going to figure out which identity we can use and then use it. So the first one, right, is addition squared, right? So that is the sum of squares, okay? So that means we're going to use a plus b squared is equal to a squared plus 2ab plus b squared. All right, our a is 2x squared, our b is y cubed. All right, and then we're going to substitute them in. All right, so we get 2x squared plus 2 times 2x squared times y cubed plus y cubed squared. All right, so we square each of these. So 2 squared is 4. X squared is x to the 4th. Plus 2 times 2 is 4. X squared, y cubed. Plus y to the 3rd power squared is y to the 6th. All right, and that's because when you are raising a power to another power, you multiply the powers. All right, so that's our answer. Now our next one are two binomials being multiplied by each other. Our A and B are the same except their operations are different, right? So this is the sum and difference. Okay, sum and difference tells us a plus b times a minus b is equal to a squared minus b squared. Okay, so our a is 3x squared, b is equal to 5y cubed. So 3x squared minus 5y cubed squared. And 3 squared is 9, x to the 4th, minus 5 squared is 25, y to the 6th. All right, so now I want you to try them on your own. All right, first one's sum and difference, and the second one is sum of squares. Okay, so try these on your own, pause it, and then I'll show the solution. All right, so first one sum and difference, second one sum of square of a sum. All right, so just use the formula and substitute your a and your b into the formula. Now, in example 2, we're going to use polynomial identities to factor or simplify. So essentially, we're going to work backwards. Okay, so say we had right, a difference of squares, right, and then we used some type of multiplication, and then we got this solution, which is the solution for a. We're going to work backwards now. Okay, so right, we're going to first have to look at the operation. We have a minus, so it's going to be a difference. Right, we don't know what type of difference though, and then we also have even, right, so squares. Okay, so what we want to do, since we know it's going to be squares, right, we want to take out the squares. Okay, so we want to find out what squared gave us 9m to the 4th and what squared gave us 25n to the 6th. Okay, so 9m to the 4th, right, we want to find out how we can take out a square, right? So we're going to undo squaring to get that 9m to the 4th. Okay, so what goes in the parentheses is what squared gives us 9m to the 4th. Same thing for 25n to the 6th, right? What squared gives us 25n to the 6th. Okay, so first you want to start with the number. So what number squared gives us 9? Well, 3 squared gives us 9. So the number inside there would be 3. What number squared gives us 25? 5. Now, what squared would give us m to the 4th? Well, m squared gives us m to the 4th. What squared gives us n to the 6th? Well, n to the 3rd power, because you multiply those exponents to get to the 6th. Right, remember, you don't add them, you multiply. Okay. Now, right, we do not have a middle term, right? No middle term. Right, it canceled out. So we know we're going to use the sum and difference. Right? Remember, sum and difference is a squared minus b squared, right? Came from a plus b times a minus b, right? So we're given this one. This is what we're given. That's what this is right here. This is a squared minus b squared. What we want to do is factor it out, right? Knowing what a is and knowing what b is, and write it into this. Okay, so our a, right, is 3m squared. All right, that was the number, that was this that we had to square to get 9m to the 4th. And our b is also the number in the other parentheses, 5n to the 3rd. Now we're going to plug that into the formula a plus b times a minus b. So I'll put in a different color. All right, a is 3m squared plus b, 5n cubed, times, right, a, 3m squared minus 5n cubed. And that's how we factor it. So essentially, you're going backwards. Instead of using the formula starting with this part and going to here, right, we work backwards. Okay. All right. So let's look at the next one. Right, the next one, we have cubes. Okay, so right, we have a cube here, and then 216 is a perfect cube. Okay, right, so they're both perfect cubes, so we need to find out again what cube now gives us that a and that gives us that final x cubed and the 216. right? So we're factoring out a cube from those two terms. Whereas in A, we factored out a square because they were even exponents. Okay, so what can we factor out? Well, what's cubed gives us x cubed, x, and what cubed gives us 216, meaning what number multiplied by itself 3 times? 6 times 6 times 6 is 216. So these are our two numbers we're going to use. So A is equal to x, and B is equal to 6. Right? We have subtraction, so difference, and we have cubes. So we're going to have to use the difference of cubes formula, right? Where we have a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Right, this is the formula we have to use. Okay, so to factor it, we're going to have a minus b times a squared plus ab plus b squared. And we're going to just substitute in these for a and b. So x minus 6 times x squared plus x times 6 plus 6 squared. And then clean it up a little bit. X minus 6 times x squared plus 6x plus 36. And that would be our factored form. Okay. All right. Now, I want you to try these on your own. And you can factor them. First one, right, same thing as a and b4, right? You want to factor to a plus b times a minus b somehow. And the other one, right, we have terms of 3, okay? So these are terms of 2, that's why it's squared. These are terms of 3, so they're cubed. So you need to find the difference of cubes, right? So it should be a cubed minus b cubed, right? So find your a and your b. So pause this and I'll show you the solutions. All right, so here's the solutions, right? You need to find out what squared gives you m to the 8th, well, m to the 4th squared. What squared gives you 9n to the 10th? Well, 3 squared gives you the 9, n to the 5th squared gives you the n to the 10th. And then you just plug it in for a and b. B, all right, difference of cubes. What cubed give you those? What cube give you those? And then you substitute for a and b and clean it up. All right. The last part of our notes is expanding certain binomials to big powers. Okay. To do this, we use something called the Pascal's triangle. Okay. You'll see the rows on the left. These rows tell you which power. So this tells you which power x plus y is raised to. Right, so to the row 0 would be x to the x plus y to the 0 power, which means it's equal to 1. And, right, it tells us what our coefficients are. Okay, so Pascal's triangle gives the coefficients for each term when expanded. Okay, the next one, right, x plus y to the first power, x plus y to the second. So that means squaring them, right? That means your first coefficient is going to be 1, and then 2, and then 1. Now, the way Pascal's triangle goes is the way we fill this out, right, is you add what's connected to it. So, right, this is going to be 1 because the only thing connected to it above it is 1. Now, we add the 1 and the 2, we get 3. Add the 1 and the 2 again, we get 3. And then we just have 1. just have 1 for x to the plus y to the fourth, right? And this is just giving you the coefficient. And then to the fourth, right? 3 plus 1 is 4. 3 plus 3 is 6. So the middle term has a 6 as a coefficient. 4, and then 1. All right, and then you can probably see the pattern going on. 5, 10, 10, 5, and 1. And then if you do get something to the 6th power, where your coefficients are 1, 6, 15, 20, 15, 6, and 1. Okay, so that means x to the 6th power, you get 1, 2, 3, 4, 5, 6, 7 terms, right? So you can see there's always ends up being one extra term from the power you're given. All right, now to help us make use of this Pascal's triangle, we use something called the binomial theorem. And it states the connection between Pascal's triangle and expanding the binomials. Right, so we use x and y, but they use a and b. It doesn't really matter, right? But, right, what's going to happen is, oh, did not mean to do that. Into right. The a term starts to the highest degree and each term gets reduced by 1 until the degree is 0. So if the first term has an a raised to the 5th power, the next one's going to be a to the 4th power, 3rd power, 2nd, 1st, and then all the way to 0 power. Okay. In the second term, so the b term with the second term starts with the lowest degree, meaning 0, or starts with 0 degree, and goes up 1 degree until it reaches the highest degree. Okay, so essentially the first term starts with the highest degree and goes lower, all the way to 0, down to 0, and then vice versa. The b term goes from the lowest degree, which means 0, and then goes up 1 until it reaches the highest degree. All right, so what we'll do is we'll use the binomial theorem to expand these. So identify the values in row 3 of Pascal's triangle. So we're going to look at row 3 of the Pascal's triangle, and our coefficients were 1, 3, 3, and 1. Right, so that gives us our coefficients. Now, our first term we see, our a term, is s, and our b term is -2. Okay, so we're going to take and put the first coefficient, second coefficient, third, and fourth coefficient in. Next, we're going to raise our a term, which is s, to the highest degree. Highest degree is 3. And then we're going to raise the b term to the 0 degree. The next one, we're going to raise the s to 1 less than the last degree. So instead of 3, it's going to be 2 now. And we're going to raise our b term, -2, to 1 degree higher than the last one. So 0 changes to 1. Then s goes to the first power now, and then the last one is 0, right? So if you want to do the first term all the way over, then the second term, that's fine. And then -2 now goes up 1 again, and then up 1 again, and you can see it ends with the first term to the 0 power, and the second term to the highest power. Then we just simplify them, right? So the first term, right, this right here simplifies to 1 as the coefficient, s cubed, and then negative 2 to the 0 is just 1, so s cubed. The next one, we get 3 s squared. Oh, sorry, not 3. So we have 3 times negative 2, which is negative 6, and then s to the second power. Clean up this one. All right. Negative 2 squared is 4. 4 times 3 is plus 12. S to the first power. And last one is s to the 0 is just 1. And then negative 2 to the third power. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. And that's our solution. Okay, so you kind of set it up big ways, and then you just reduce each term to something looking nice, right? Rather than having to do all these foilings and things like that. All right, so let's try B together. So identify the row 5 because it's the 5th power. So that's the power. X is our A, our B, right? So 1, and then the 5th row goes 1, 5, 10, 10, 5, 1. So we can fill in step 2, the 1, the 5, the 10, the 10, the 5, and the 1. We can also fill in our x term, right? It starts with 5, goes to 4, goes to 3, goes to 2, goes to 1, goes to 0. And our y term starts with 0, 1, 2, 3, 4, 5. Then last step is clean it up. Right, we get x to the 5th for the first term. Second term is plus 5 x to the 4th y plus 10 x cubed y squared plus 10x squared y cubed plus 5x y to the 4th plus y to the 5th. And there's your solution. Okay. If you try B, use Pascal's triangle to expand this. And then I'll pause it and you can check your solution. And then also try C. So I kind of just spread them out, but and then I'll give you guys the solution once you pause it. All right, here's the solutions for expanding them. Okay, so part B, I kind of wrote out all the parts to it. And then C, I kind of just gave you the solutions. So if you have any questions, just let me know.